When you said agent-to-agent communication, they're using quantum encryption, is that right?
Right.
Which means it can't be cracked with today's technologies.
Yes. So we want to ensure that when you are using the atomic building block of that powers all of human work moving forward, you want to ensure that it's quantum safe, secure.
Yeah. What is an Internet of Agents?
Great question. And so the Internet of Agents is an open, interoperable internet for quantum safe agent-to-agent communication.
Okay, you got to break that down. Everyone, it's David Mobble coming to you from Cisco Live, back with Vijoy. Vijoy, great to have you back on the show.
Always a pleasure, David.
So you work for a very interesting group within Cisco. You've got to tell us about it and, sort of the visionary stuff that's coming.
Yeah, so I actually run an outfit inside of Cisco called Outshift, and it's Cisco's internal incubation engine. And our charter is to build products and ventures that take Cisco into new markets, adjacent markets. And we are structured that way. So we are structured like a bunch of startups within Cisco. So we've got product and engineering, of course, but we've got marketing and customer success and sales all rolled into this team so that we can build something from idea all the way to market reality.
You've got to tell me, you're working on the next thing or things in the future. Are there any cool and interesting things coming?
Are there? I mean, I think we are working on our boldest vision yet.
Oh, is that right?
Yes, and we call it our bold, hairy, audacious goal, or BHAG, and that's to empower Cisco to lead the Internet of Agents revolution.
What is an Internet of Agents?
Great question. And so the Internet of Agents is an open, interoperable internet for quantum safe agent-to-agent communication.
Okay, you got to break that down.
Let's start with open and interoperable. So it is an internet that connects agentic software. Now that agentic software could be in various shapes or forms. So the simplest thing that people think about is agentic software within business applications, SaaS applications. And you've heard everybody talk about SaaS applications being replaced by agentic software. I mean, Nadella was on BG2 podcast talking about agentic software plus raw data being the next business application. So that's the most common thing that you can think about. But agentic software is sitting inside your phone. Like it or not, Apple Intelligence is agentic software or is aspiring to be agentic software in the future, right? There's going to be agentic software within scientific applications. So you see a lot of this, and this is where I think I'm the most excited about, where protein folding and protein discovery or drug discovery, material discovery. I mean, these are all scientific applications where foundation models and agentic software is going to do wonders for humanity.
Is agentic software the same as agentic AI?
Agentic software is agentic AI, and I'll come to that in a second.
Okay, great.
And I'll define that because that's a great question.
Because I was wondering what is that exactly. So sorry to interrupt you.
So let me come to that for in a second. But yes, you've got scientific applications, you've got social applications, and one of the things that Zuck is doing is the reason why he's spending so much effort behind Llama and the whole open source movement is to enable social interactions with agentic pieces of software or avatars, and that's the next generation of social networks. But the big one, again, in addition to scientific applications, the other big one is agentic software within physical embodiment, within robotics, to solve for physical work. So you've got business work, you've got consumer applications, you've got scientific applications, avatars and social applications, as well as physical applications. So all of these embodiments of agentic AI need to come together, need to collaborate, and you need a platform for that collaboration. And that's what we're trying to build with the Internet of Agents. So I can dive into what AI agents mean. So agentic software for us is foundation model or model-based software that has agency. And what does agency mean? It's actually you allow it to take action on your behalf. So it's autonomous, it can take action, and that's the simplest definition. So it's foundation model-based or simple traditional model-based or a combination thereof, pieces of software that can take autonomous action and agency. But there are other things that need to be true. So it needs to have access to tooling that allows it to take action. So it needs to have access to APIs. It needs to have access to transactional software to allow it to take action. On the other side, on the input side, I mean, you've seen AI assistants, and they're very passive in nature. They're waiting for you to provide a push input, ask questions, right? Agentic software is going to be always on. It's always on, listening to the environment around it, so that then it can take action on your behalf. So there's a whole bunch of related sort of inputs and outputs that it needs to have. But the basic idea is it's model-based, foundation model-based, and it can take action autonomously on your behalf.
So it's something that's interacting with an LLM, right? And then or perhaps interacting with that. But give us some more details. Sorry.
Yeah. So LLMs, yes, and that's true today. But if you think about the wide surface of human work that I just talked about, we are here at the precipice of disrupting all of human work. And so LLMs are just the starting point. And to me, large language models are one kind of foundation models that actually deal with the language of humans. I mean, there's like natural language primarily, right? Or content, if you take a broader stance.
Yeah.
But languages appear in the world in various other shapes. And so they're going to be world models, right? They're going to be models that actually understand the physical environment that we sit in, especially useful for robotics and so on in the future. They're also going to be models that I described, for example, that understand the language of how proteins fold and interact. That's scientific. They're going to be models around how materials form and interact. So each one of these areas has their own language, their own grammar. And LLMs, by definition, are languages that we speak, and they interact with Japanese or English or images and text and audio. But there's a lot of other languages. There's mathematics, and there's a lot of other languages that foundation models need to interact with and be based on. So taking a step back, when I say agentic software is software that contains foundation models, it's way beyond LLMs. Yes, LLMs, but also world models, but also scientific models, mathematical models, and so on and so forth.
I'm so glad you said that, because when I was researching this, it seemed like agentic AI was just something in addition to LLMs.
It's a lot more. And I think, as with any piece of technology, you start with a seed and you provably make it work in certain use cases, and then you expand out. And we've been on this journey for a while now. This piece of technology, which is foundation models and generative AI, we've been working on neural networks all the way from the 1960s. There was a 2017 transformer movement. There was a ChatGPT moment in 2022. We are expanding out into all of these other fields, scientific discovery and world models for robotics, and there'll be a lot more. In fact, agentic AI, we're just at the beginning of that journey. There's a lot more to solve. In fact, if you hear some people speak about it, like Jan LeCun and others, they say, we're just starting out. In fact, LLMs and foundation models are going to look very, very different. We may not even call them generative AI in the future, because they need to have certain other characteristics that we have not solved really. So we have not solved persistent memory. In fact, these things don't have memory. We have not solved planning and reasoning. So these models can't really plan right now, and they're really poor at it. Yes, you're getting to some level of reasoning, but it's not there yet. We need some fundamental changes. And then, like I said, they need to understand the world around us. And that's also something that we're just starting out on. So there's a lot of fundamental things that we need to solve. So it's an evolution. It's a journey. And LLMs are a snapshot. The generative AI that we know of today and the agents that we build right now are a snapshot. But there's a lot of work that needs to be done. But agentic AI is a journey that we're on, and they're going to happen. A train has left the station. I'm mixing metaphors. I don't know. So if you think about agentic software, and if you think about this broad statement that I just made, which is agentic software is the new unit of work that is going to disrupt all of human work. It's going to happen. And if you think of that, it's going to happen in a way and shape or form that humans are used to, which is you can't have a singular entity. I mean, I don't go to you, David, or you don't come to me and ask me questions about technology, but then switch around and ask me a question around chest pain, or you switch around and you ask me, plan my travel for me. You don't do that. I mean, I don't have answers. I can give you answers. They're BS answers. I mean, so take it with a grain of salt, but that's what's happening right now. And we've made that transition from that, which is one-shot or zero-shot approaches, to where we have an ensemble of agents that will come together to solve for any problem, right? And so we proved this in the software development world first, where we said you'll have an agent to develop software, generate code, but then you'll have software that deals with scaling. You'll have software that deals with security, and that's no different than how teams come together and subject matter experts in security and SREs for deployment and code developers all come together to build pieces of software and to launch software and deploy software. The same thing holds for agents, and you will see ensembles coming together and subject matter expert agents coming together to solve for a problem. And so by definition, you'll have best of breed agents specifically suited for certain tasks that I as a consumer or a workflow developer would actually want to bring together as an ensemble and solve for a particular problem. That best of breed is going to come from a variety of vendors, will get used in various organizations, will take on various access controls, will have different contexts, and will have different profiles and personas, just like humans. And so where is a platform to bring them all together, help them collaborate, and then solve for the problem? And so that's what the Internet of Agents is, and that's what agent-to-agent collaboration and communication is. And there's some pretty unique challenges here. So every time there's a new asset class, whether it's social circles, whether it's servers, whether it's cloud endpoints, you need secure connectivity infrastructure, collaboration infrastructure to bring them all together. Same thing with agents. So you need to solve for the problems of discoverability. Can I discover agents that do task X or Y? Are they reputable enough? Are they best of breed? Can I authenticate them? Because I need to give them access for agency, as we discussed. And then I need to connect them so that they can then collaborate and solve for the business problem. So we are trying to build a platform for doing exactly that. Discover, look at reputation, authenticate, connect them, and then let them collaborate. And once they start collaborating, there's some truly unique challenges for agent-to-agent collaboration. There are challenges around agentic software being non-deterministic in nature. So you have non-deterministic intent, there's non-deterministic output, there's probabilistic output. Find me the best X. This is the best X with 90% confidence. How do you build that into the platform, the collaboration platform? Then there's large state exchanges. All of these agents are going and doing multimodal state exchanges, text, code, audio, video, images. How do you handle that efficiently on this collaboration platform? Evaluating a singular agent is hard enough. Is it really doing what it's supposed to do? When you tie all of these things together in an ensemble, in a graph, in a call graph, boy, oh boy, I mean, that's a tough problem to solve. So assurance and evaluation in that agent call graph is a tough problem. So I'm just listing 3, but many such problems that are net new that this Internet of Agents is actually trying to solve. And we want this to be open and interoperable is the other key thing, because open systems drive innovation. You remove the organizational political friction that exists in closed systems, but also you drive maximal value for everybody in that value chain. So whether you're an infra developer, application developer, whether you're an operator, or you're a customer or consumer, for all entities in that ecosystem, an open system provides a maximal value. So it needs to be open and interoperable. And then finally, it comes to security.
I was going to say quantum.
Quantum security. And the reason we firmly believe that quantum security is key in this collaboration platform is I truly believe that the ChatGPT moment for quantum computing is going to happen. And it's going to happen not in the next 20 years, as you heard others say. It's not here in the next year for sure, but it's here in the next 3 to 5 years.
Interesting.
And when that happens, catching up is actually going to be really hard, because unlike other transformational changes that have happened in our industry, and let's just take IT and technology as the industry, it's all been a matter of software, a small matter of programming and small bias software. Quantum is changing everything at the bit level. Whatever you've done and whatever you've learned, throw that out and start from scratch, right? So a bit becomes a qubit, quantum bit. And everything else that you build above it, from quantum nodes and networks and security, all of that, that entire stack, distributed computing, is all going to look very different. The principles, the fundamentals change. All the theory that all of us learned in school, throw that out. It's brand new.
Yep. And 3 to 5 years, wow.
In 3 to 5 years. And so we are going to see practical use cases in the next 3 to 5 years. It's not going to be completely pervasive, but some really needed use cases will happen in the next 3 to 5 years, especially around optimization, especially around security. And I think that's where we as Cisco feel that 2 things. First of all, this internet that we're building this new internet for the next 40 years. We just had a birthday. We built the original internet. Cisco was a key player in that. How do we build the next gen of internet that has the next gen of security baked in? Because you take the current internet and you want to migrate it to post-quantum cryptography, it's a decades-long migration path. I don't want to be in that migration mess when we're building something that new. So let's build it right. Let's build it quantum safe right from the get-go. So that's one aspect of quantum. But then the other aspect is when these quantum compute nodes come online, when they start enabling real quantum workloads, we want Cisco to be the networking provider for those clusters, for those quantum clusters. And the other thing is quantum clusters and classical compute will coexist forever. So we want to be able to bridge between quantum clusters and classical networks and classical compute nodes with Cisco technology as well. So that's where the other bit is that we're going after. That's the bet that we're going after as well.
When you said agent-to-agent communication, they're using quantum encryption, is that right?
Right.
Which means it can't be cracked with today's technologies.
Yes. So we want to ensure that when you are using the atomic building block of that powers all of human work moving forward, you want to ensure that it's quantum safe, secure when it collaborates. Because it's one thing to have agentic software or assistant software with human interaction. Is the other thing when you let this thing run at machine scale autonomously, taking action on your behalf and running it on old-time security.
Yeah, that was the next question. Yeah, go on.
So you need to make sure that when you have agent-to-agent collaboration and communication, from the get-go, from the development stack all the way to the communication stack and the network that's the Internet of Ages that sits below it, it's quantum safe so that even if there is a store now and harvest later attack, which is people are tapping in somewhere, and making sure that there is an agent in the future that runs on a quantum island somewhere that can make all of that communication plain text, good luck, because we will be quantum safe. So there are many, many technologies to make things secure. So we want to have something that is post-quantum cryptography. So PQC is something that you can do in software. And we want to start with that. So just making sure that the software bits are secure. But then even after that, we're going to layer more and more quantum safe security measures above PQC that make it harder and harder for somebody, even having access to quantum nodes today, being able to crack that communication layer between agents.
Does that exist today, the quantum encryption?
So there are some standards that have actually been published by NIST that talk about, they're called post-quantum cryptography communication standards, and you can roll it as part of the TLS stack, as an example. But it's like I said, it's a decades-long migration path today because it's the software that people have used to build their applications, but it needs to be tickled and it needs to be enabled. And so it's both the compile time as well as the run time that needs to change. And it needs to change for not just software you're building starting now, but imagine all of the software that exists. That's like decades. So I don't want to say impossible, but it's a hard problem, right? So there is PQC. The other problem with PQC beyond the migration path is that we started with 4 or 5 alternatives to the current RSA or the other mechanisms that exist in TLS.
Yep.
And out of the 4 or 5, a couple of them got broken into on a laptop. And so the problem with software approaches is always that you can always break software approaches. It's not provably quantum safe. So the real way of tackling key exchanges and making things quantum safe is to do it at the quantum level. And so some of the things that we're working on is enabling security using quantum physical properties to do the key exchanges so that you can be provably assured that if somebody is sneaking in and snooping in, you will get a signal from the physical properties of that wire itself.
It's amazing.
And you can tell that somebody is sneaking in and trying to eavesdrop.
I love what you said there because it's exactly that, right? If you store it somewhere, someone's at some point probably is going to hack in.
And in fact, it's not probably at some point. We are getting to that threshold of that, right? So if you think about some of the recent announcements that Google has done on the quantum compute side or even IBM, we are getting to the scaling laws of quantum where we say you can stitch together a bunch of these quantum nodes. Yes, there's a lot to stitch together right now. But I would say in the next year, it's fewer and fewer. And so you could build a distributed quantum cluster that can actually crack encryption. And this is what's being shared publicly. So you don't know what's out there. Yeah, so I think what we're after is as all of human work gets disrupted and the new unit of work is going to be agentic software that sits in this various forms of physical, social, scientific, business work, and they all need to come together to solve for a business for a problem. We need a platform for all of these agentic pieces of software to collaborate, and we are building exactly that platform, which is the Internet of Agents. It needs to be open and interoperable for the variety of reasons that we just discussed, because it's the only way to solve for this. And if you're building the next generation of internet and the next generation of collaboration, let's make sure that it's quantum safe right from the get-go, because this internet is going to exist for the next 40, 50 years. And you don't want to be in the migration mess when, not if, quantum nodes come online and security becomes a huge problem.
Cisco recently had its first AI summit, and one of the things that I heard there, and you've mentioned it again, is robotics. So is that a reality that we're looking at soon, where there'll be robots in people's homes helping people physically rather than just software?
Yes, and I think so homes, yes, but also even if you look at places where robotics have been pretty commonplace, the big shift is the way robotics will evolve. And so just if you think about the evolution in ML, so we've gone from ML models which are purpose-built to now transformers and generative AI and LLMs, which are more general purpose. And these models can actually pick up tasks and skills easily. And so what's going to happen is robotics are going to go through the same evolution. So even if I ignore the home part for a second, but even if you look at, let's say, manufacturing.
Yeah, Amazon or whatever.
Or car manufacturing or whatever, right? So if you think about robotics there, you have purpose-built robots that are painting the car day in, day out. You have robots that are like putting this nut and bolt on day in, day out. And these are purpose-built robots, but what we are going to see anytime now, and it's happening right now with a bunch of players out there, that you're going to have general purpose robots that pick up skills. So you manufacture once and deploy many.
Okay.
And so you're going to see these robots which actually go from working in an Amazon warehouse to working in a retail environment in Starbucks to actually going and painting a car in a manufacturing environment. But it's the same robot. And you can add skills to it like the way Neo gets skills in the Matrix. And that's what's happening.
I know Kung Fu.
Because guess what? That's how humans actually get trained as well. You go in and you say, take this box from here, put it here, and then you use this instrument to do this task and so on and so forth. The foundation models being built around world models actually will enable this. So what's going to happen is robotics will have general purpose actuators that can do many, many things. Instead of just doing this axis, they can do many axes of work. And then you're going to have foundation models that actually understand the environment and the world around them that can help them pick any kind of skill. So the combination thereof, and then LLMs for you to interact with these robots in a natural language way is the third bit. So all these three things components together will actually make general purpose robots that even in existing environments will take us away from purpose-built to general purpose robotics. And of course, the next step is homes and office spaces and so on and so forth.
I got to ask you this, because I know people will be thinking about this. Are we heading to the world of the Terminators, or is it hopefully not going to be that way?
I do not believe in the Terminator world, because I think in the end, we build a replica of us and we actually control the replica of us. I mean, if that were the case, then cloud software would go haywire and networks would go haywire. There's always a big red button. And I know the audience is very much an operator audience. This audience will be here. This audience will help manage and deploy and scale these things. There's always going to be a human in the loop. It's going to work at a higher layer of abstraction. Nobody writes code at machine level anymore. And it's going to be the same thing here, right? We will punt things that we shouldn't be doing, and we will look at broader and bigger problems. But there's always going to be humans in the loop.
Is it a good time for young people or people switching career to get into this technology?
Absolutely. I mean, what are you waiting for is my question. And I think in any situation like this, I mean, the one thing I'm reminded of is, I don't know if you're a Pink Floyd fan, but there's a song called Time. And it's like, no one told you when to run. You missed the starting gun. Please don't be in that boat. Let's start. The time was yesterday. Let's get moving.
Vijoy, thanks so much for sharing and giving a positive message. It's fantastic to talk to you about the future, because I think a lot of us are worried about where the world's going. Thanks so much.
It's always a pleasure, and it's always a fun conversation. Thank you.